Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard. This is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we talking about today?
Hello, let's talk about query optimization, like second step, third step after you identified, maybe third step, right? But first step is you found some queries which behave not well. Second step, you found some optimization idea. And what's next?
Yeah, exactly. How do we know whether it would be safe to make the change that we're thinking about, whether it will make a difference, that kind of thing?
Yep, and this is one of the topics our listeners requested.
Yeah, exactly. I think they phrased it quite nicely. It was like a 102, I think they said, like the American classes, like in terms of university courses, right? Is that how it works? 101 is the intro and then 102 is the next step along?
I'm not the best person who can explain this, but yeah, I saw it. 101 is everywhere, right?
Yeah.
So yeah, where to start? Let's think about first. Let's maybe make a step back and think about how we verified our optimization idea. As usual, I have strong opinion here because I see a usual approach is to rely on experience or to test it right on production. Because the usual problem is that non-production environments, they have different data, different size of database, everything is different, sometimes different hardware, but actually hardware is less important, much less important. We can tune our Postgres on a weak hardware to behave in terms of plan choices, to behave exactly like on production. It's possible, but the data, statistics, and planner settings, of course, these things are the most important. So, question is how you verify your ideas. How do you do it? And the answer, great. So, what do you think?
I'm interested. Yeah, well, so I think you've probably gone really advanced there already, talking about how hardware is less important. I think the first lesson is that testing in a similar setup as possible is really useful. And maybe there's some exceptions to that, but by similar, I think the first thing I always try and encourage people to do is make sure the quantity of data is similar. So, and I guess we're testing two things, right? The first thing we want to test is, does this actually improve from like a micro perspective for the single query that I was trying to optimize, or for the single problem I was trying to solve? Does this solve that problem? And then there's a secondary level. Does it introduce other problems, or does it work well amongst the whole load of the system?
Down anything, right. But so we want our non-production Postgres behave like ideally exactly in the same manner as production would do it. Actually, production can change. Yesterday it chose one plan. Today there is no guarantee it chooses the same plan, and this is quite well known in Postgres. And unfortunately, Postgres doesn't provide a good way to solve this problem. I mean, to freeze the plan choice and avoid plan flips, sudden plan flips for critical queries. But it's another topic. So. This is another topic. Just I mentioned it just because to give the feeling that the planner behavior is not stable. So achieving the same planner behavior on non-production environment, it's quite a challenge, right? But there are specific tricks that can help us. For example, of course, ideally we want the same data, because the same data will mean PG statistic content is the same, so we are fine. There are tricks to export-import PG statistic content even if you don't have data. There are some not very popular but interesting extensions. I think they came from Japan. I don't remember names, but I can provide links. We will provide links. It's possible to export and import statistic. This approach has limitations. It's similar to hypothetical indexes, partitions. Very interesting approach, and sometimes it's good. But what if we want like true behavior? Executor really executes our plans, and we can see the the behavior of Postgres for our query. In this case, we want the same data. Of course, there are several levels of how we can be close to the same. We can just take it as is on physical level. This is the absolutely good approach. We just grab the same PG data. If we have managed Postgres, we just clone it. Most of managed services allow to clone. It takes time, it costs money, but it will give us the same data, and so we can see behavior there. But sometimes we cannot copy on physical level, so we can only copy on logical level. But as you said, the numbers of rows, for example, will be the same, so we're good. Unfortunately, right.
A problem, not really in the topic of performance, but a problem I see quite a few customers coming across with that is the kind of access to data. So giving developers access to production data can be problematic from a privacy point of view.
Yeah,
okay.
Yeah. It's very problematic. And in my opinion, it's not about... there are two problems that access of arbitrary developer and company to production can bring us. First problem is security. And second problem, I think it's more important, even more important. Security, we can ask them to sign something, to do security trainings, a lot of things. But second problem is more interesting. Developers want to develop, so they add a lot of instability. If we allow developers to go to production, it can introduce challenges in terms of stability, because we want to have the established process of development, testing, and deployment. So we don't want developers to go and check, for example, oh, I have a great index idea, I will create it right on production primary node, and I will check. It's not good. So, right, but security is also a concern, but even if we don't talk about security, which is a very big concern, if we need to use logical copy of production, for example, question is, will plan be the same? Row counts are the same, right? Statistics should be the same. And for example, we took the same hardware, and we put the same Postgres settings to configuration. Question is, does it guarantee that the planner will behave in exactly the same manner or no?
So the place my head's going to is using Analyze, and it sampling. Even when you run Analyze, you need to get samples of tables, right? So maybe that's not the only way it could be different, but that's one reason it could be.
I agree. Yeah. Some instability there, but also if you have a lot of bloat, for example, rel pages is different. So on your new node, on your logical clone, rel pages will be smaller, and this directly affects the planner behavior. So it can choose different plan. So you can see different access nodes and plan, not access nodes, execution nodes and plan when you compare production and this logical replica. Unfortunately, and I don't know solution to this problem, but it's quite interesting problem. So
and actually, not just bloat, also I guess insert order, right? Like correlation of
physical
data
distribution. Yeah. Well, this you mean the buffer numbers will be different. This I understand. Yeah. For example, we need to read 1,000 rows. We had 100. We had 1,000 of buffer reads and hits on our source, but we have only 100. Or we have like much fewer hits and reads on our replica because more compact storage, for example, of these rows. This is possible, right? But question is, will structure of the plan will be the same? And answer, unfortunately, we cannot guarantee it. Usually it's very close, but unfortunately, rel pages is different, and it directly affects the planner behavior.
But we're talking about edge cases, right? Not the majority of the time. If we're talking about simple OLTP type queries, does it use the index? Does it not? The kind of things people are probably worried most about, they're likely to be easily replicated once you have a similar sample of data.
Right. So the I agree. And sometimes, for example, we might have multiple production environments, and they are slightly different. So things can be very interesting in various cases, but at least we can be as close as possible if we aim to do it. We say, okay, we have a billion rows on a table. Let's have a billion rows on a table in our production environment, non-production environments. And then we can see the plans. Now back to the topic. If we have a plan, if we have a query and a plan, and now we want to ensure that it's a good idea and we need to approve it. Of course, direct comparison before and after, it's already good. Right, so we have one query and we see that our change, for example, we create an index or we do something else, we change query somehow, we directly see that IO numbers improved. So conclusion is let's do it. But as you mentioned in the very beginning, of course, there are some cases when our change can affect other queries. And the question is how to find it holistically, how to test it holistically. And this is an unsolved problem. First of all, let's consider one case when it can be possible. I had it and I wrote an article about it. We will provide it. So it's like an interesting case when optimization of index led to all updates being worse in terms of execution. Why? Idea was simple. For example, we have some select. It's quite slow, and it's not, maybe not slow, but we see that it uses some index which we can reduce in size significantly, adding a where clause. We add a where clause, everything fine. This select has better performance because index size is smaller and so on. Because now it's partial, smaller, right? But then we deploy it and suddenly you see that latency of all updates on average reduced. Why? Because we lost hot updates. Because adding some column to index definition, even it's in the where clause, leads to different behavior of updates. Because updates, hot updates, heap only tuple updates. They are possible only if no indexes have column name in their definitions, that column which we are changing.
Yes.
Right. So if we change some column, usual case, for example, updated at a timestamp, we usually tend to change it when we do updates, right? Because it's the semantics of this column. But if we have an index on it, no such updates can be heap-only tuple. Heap-only tuple updates, they are much faster than regular updates because during these updates, Postgres doesn't touch all indexes. It doesn't need to change all indexes. But with regular updates, Postgres needs to update each index. And this is called index amplification, index write amplification issue. One of those which Uber highlighted in their article. So losing hot updates may be painful. So, right.
Especially on a heavily loaded system, for sure.
Right.
Right. The place I am starting to see some progress on in terms of tooling is people even being aware that some of these things are a problem. So, it's PG Analyze added an index advisor in the last year or two, and one of the things that it points out is an estimate of write performance overhead. So not only can indexes be a problem in terms of preventing hot updates, they also add write overhead for new rows, for example.
Oh yeah, any index. If you create one more index, definitely you add overhead. Definitely, yeah. And we can actually estimate. We can measure it. It's possible to measure it, and this is interesting. And this definitely it's possible to improve tooling. Definitely, I don't see best tools here. I made couple of attempts to create tools. One of the ideas was to create a benchmarking tool which will be used in any change related to database. It was called Nancy bot, and the idea was we will replay workload before and after our change. We will collect all metrics, for example, from PG-star statements, from logs, auto-explain, everything. And then we will provide the direct comparison before and after. Before and after, and we see exactly which query is degraded and which we are fine, which query is improved. And this was great idea. We even had a good interface and so on. But then I realized that practically it's not possible to run full-fledged benchmarks every time developers does any change, because it's just economically doesn't work. It's too expensive. You need separate machine or a couple of machines, sometimes several in a batch. Sometimes we ran several experiments, like what if we do this, like we have 10 options and we executed them. Then questions arise like we executed them in parallel, not sequentially, because sequentially is too slow. If each experiment takes 10 minutes, you want to execute it in parallel. But then questions arise, okay, but what about, are all virtual machines the same? Or there are some deviations, for example, one of them got worse disk or CPU or something. So we
or noisy neighbor, yeah.
Right. So we added a lot of logic, micro benchmarks to ensure that some baseline is met, and so on and so on and so on. And complexity grew, but the main problem was you just need to pay a lot to do such experiments. Some companies can afford it, but also one of the biggest problems was how to replay workload. There was PG Replay and PG Replay Go. I saw maybe yesterday, I saw the article from Frank Pachot, Yugabyte, about how to run PG Replay for Yugabyte, or PG Replay Go actually for Yugabyte. But collecting queries is also a challenge, and I did it several times. And so the bottom line, it's quite complex. It's possible to do it. Some companies actually implemented something, but it's very hard to create a universal tool here. But still, there is need here. There is need. We want to cover all changes with some testing, right? But the good news here is that we don't need full-fledged clones. We can do in a shared environment. We can focus on I/O metrics and run many experiments on just one machine. This is what we do with Database Lab and thin clones and database branching. And it's possible. So we can have thin clones. Of course, they have different timing because different file system, for example, ZFS or anything else. Bitreface is also an option. And then you run multiple experiments right on one machine, and you don't care about timing, you care about plan structures and I/O numbers, and you can verify many things. So next question is what to verify. Okay, we have our query we want to optimize. We found some index idea. We verified that query is improved. How to check other queries? Well, some new tooling needs to be built here, right? And I think it consists of two areas. First area is a reaction. We need to reactive approach. We want to grab the content of PG-star statements periodically from production and have some regression testing. We can reduce the scope if we can parse queries, already normalized queries, using PG query library from Lucas Fittle, right? To identify which tables are involved. And if we consider optimization for a particular table, we can find only those queries from top 100 or top 500 by total time, by calls. Somebody needs to decide what is the most important metric and which queries are most critical for our application. But we can find those queries which potentially might be affected. Of course, we can also think about triggers and various dependencies, foreign keys, and so on. So this is tricky. But anyway, we can find it automatically, and using thin clone, using single connection, sequentially we can test many queries, but the problem will be how to find parameters, which parameters to use for those queries. And this is unsolved problem. I already mentioned it. This is big problem. Which parameters to test?
In reality, what do you see? It's like in reality, that what I see people doing, and I think it's probably at a smaller scale to you, is that they reason about the potential effects, discuss it amongst the team during the PR process, during the discussions, then they monitor. Well, they deploy to production and monitor. Maybe they provision a little bit
A
extra.
purely reactive approach, right? So
Exactly.
we deploy and see. Yeah, this is possible. First of all, of course, code review helps, and having a bunch of very experienced Postgres experts helps a lot, right? They can say, "Oh, you know, this is good idea, but what will happen? What's overhead from it? Let's think about it." Of course, we can manually analyze and try to predict. And if you have experience 10 plus years, it will work quite well, unless you're very tired, very busy, have days off, and so on. So I still think about a fully automatic approach, but it's possible, and we can check metrics and have some alerts. For example, if updates are very important for us, if the ratio of hot updates dropped after our release, it can be somehow flagged, alerted, and so on. This is a good approach, yes. But it's purely reactive, right? And actually, most projects they don't have this. So I agree, this could be a good step towards it. But back to fully automated fashion,
Yeah.
which queries to check? We need to check queries from production for regression testing, and that's possible. And we actually, in a couple of cases, we already have something like that with our Database Lab engine. Everything is done in CI/CD. And users see the difference and potential degradation before we deploy it. It's very good. But additionally, we need to think about absolutely new queries. For example, if it's a new feature branch, and it introduces some new queries or heavy rewrite for existing queries, production doesn't have these queries. So second part of it is even more challenging. We need to test absolutely new queries here. And I'm just explaining our thoughts. We moved in this direction and with Database Lab. And I'm excited that in future we will have fully automated testing of all things related to databases, even for those who are not experts at all. And when experts are involved, they have a lot of artifacts, metrics to analyze and understand much quicker what to do, how to fix it. So everyone can move faster and with better quality and so on. Right now, without this tooling, idea is right. We need to have code review and every database schema change. We need to test the change itself, but also think about how it will affect workload.
Yeah. And I guess first step, some people don't even check about the locks involved, right? That's like, I guess that maybe that's 101 rather than 102. But making sure that it's not a blocking change. I know this has got a lot better in more recent Postgres versions.
But this is, I even don't discuss it, considering it's too trivial. But right, so like create index should have concurrently, and updates should be in batches. Yeah, and this is actually, we solved with Database Lab. We have fully automated verification that no exclusive locks last more than specified number of seconds. For example, nice. 1 second, or this is possible to fully automate for the change itself. But like, we spent some time understanding how to test the change itself, and quite already solved it. We can put it to your CI/CD. But now question is, I think it's a bigger question. For example, some developer created something but forgot index. How to see that it will be bad if we deploy this? And how to see it without involving very, very expensive and very experienced DBAs every time, right? So we should involve them only if we have a hard question, not a simple question like forgotten limit or index which degrades our other queries and so on.
Yeah, and I was you mentioned PG Replay Go. That's from the company I used to work at, Go Cardless, and I think that's how
exactly.
they reason.
Right. Yeah.
Yeah. So I think that's how I remember it being used most. It was big changes. It was risky things. It was things that people already knew were potentially problematic.
For
So
example, big functionality, we deploy big functionality, or we had some refactoring during several months, right?
large migration, that kind of
Right.
thing.
Right. Well, in my opinion, benchmarks with multiple sessions should be applied very rarely when something big changes, either like big new release happens, or migration to newer Postgres, major Postgres version, or change of infrastructure, change of operational system. It happens a couple of times per quarter maximum, usually, right?
Yeah,
Even in
much less normally.
much less normally. It doesn't depend on the size of company actually, because anyway, it's very expensive change usually, and it's a good that we need benchmarks, full-fledged benchmarks, so not every day, but application changes might happen every day, sometimes several times per day. And they might change some small part of database. Good news, only small part of database, right? We don't perform huge refactoring every day. So if we change only one table, two tables, we should be able to test it in more light manner. This is why I'm so big fan of thin cloning, and I'm so excited to see others also think about database branching. Neon database, they say about it, like they say you can test a lot of things in CI/CD. It will be cheap. Actually, Aurora has, as we discussed, Aurora has thin clones, but it's not cheap. You need to pay for each clone for compute power separately. I hope Neon will be different, so running on one machine, and you pay for a single machine, but run many tests at the same time on one machine. Otherwise, it doesn't scale, because you sometimes need the dozens of tests happening in parallel if you have big organization. It can be very costly. So you will turn it off and you will be without testing, returning to bad times again. But right, like the advice right now is yes, have database reviews, try to automate some things, learn your pgstat user tables, right? Because it shows you how many updates and hot updates you have. Some tuple statistics, it's very good to understand it. I don't agree with a Datadog approach. If you go to database dashboard in Datadog, they have a lot of improvements lately over the last year or two. But if you check what they name, they present it as throughput, tuple statistics. No. Throughput is TPS, QPS. This is throughput. Our global throughput for our database now. But tuple statistics is important, but it should be like it's in details. Should be in details. But it's an off topic. Anyway, understanding when you change something for a table, understanding tuple statistics from pgstat user tables, it's a good thing to have, right? And you can see, oh, I lost hot updates. Oops.
Yeah.
Right.
How would your advice change if we're talking about smaller teams? If we're talking, let's say, like you're a 6-person startup, you've got a decent amount of data, but not necessarily, not billions of rows, and maybe the team is currently prioritizing moving fast, and if they have a few problems that they have to fix, that's okay. Is there any changes in this? Because this feels like a very safe approach. Like the kind of tooling we've discussed seems very much optimized for try to avoid a problem at almost any cost.
Well, yeah, good question. First of all, I would anyway change mindset to use buffers instead of timing. Anyway, yeah. Even if you're small, because it will save you so much. Of course, there is such thing as a premature optimization when you try to optimize too early, too much. But still, if you know that this some table, you will use it as in the queue pattern. Insert, update, and delete. Insert, update, delete. It will be bloated a lot. You need some experiment anyway. This experiment, by the way, can still be single user, single session experiment in shared environment, because you don't actually need to use pgbench and utilize all CPUs. You don't need some kind of background workload, unless this workload also deals with your table. What you do need is to think about the future, like what will happen 1 and 2 years with this table, how big it will be, and run some benchmark with one session to fill it, and then to run one more session to next you run to update it heavily and so on, and see how bloat will what bloat will be. And do you have good indexes here or no? Like, if you focus on buffers, you will quickly, this mindset change is very important, because you will start comparing, like in your tool, pgMustard, you compare, for example, rows, buffers, buffer numbers. To get one row, we deal with 1,000 buffers. It doesn't feel good at all. So, and if in 1 year it will be even worse, probably we should prepare for better growth right here in this area. So we need to test it. We need to test our queries and see what will happen if we have more data, for example.
Yeah, right. I think the only other thing I would add is I think I see kind of a couple of extreme failure cases here. I see the failure case where people have not really started adding many indexes at all. They almost have no indexes, and then they start to scale and they have every
or index every column, right? Yeah.
Or exactly. Or the other extreme where they've added an index every time they've seen a problem. I've not seen an every column case. I've heard about them, but definitely, every time they see a potential for a multi-column index, they add one. So a single table even a table with 6 columns could have 20 indexes on it, different orders, different. So I've seen both of those failure cases, and I guess if you know you're in one of those, then it kind of changes your approach quite a lot. If you're we already have too many indexes, maybe you need to be a bit aware of that and be looking at reducing that. If you know you're in the case of we don't have enough, maybe you've got a little bit more leeway to not have to worry about as much impact of adding extra
ones. Need to understand your workload to know what to test. And like, this is true, but again, change of mindset to buffers and just experiment a lot. This is a good thing. Like, experiment, and you will see, and then you will probably start, if everything is based on human decisions, based on gut, right? In this case, probably you will start skipping at some point you will start skipping some checks because you already know that it's okay. But sometimes you will be wrong anyway. This is a bad thing.
Yeah, in fact, the buffers thing came up. Just the other day, I saw a really interesting blog post from a company that moved from Postgres, RDS for Postgres to Aurora for Postgres.
Okay.
And they, in my opinion, must have not had enough indexes. They must have been doing too much I/O because their costs went maybe tripled or something according to the graphs. And it was really interesting to see that they thought this simple migration would be straightforward, but actually because they hadn't optimized for buffers, they hadn't reduced, being quite efficient on the I/O front, that hit them with a big bill and some headaches.
On Aurora optimization, it's not about performance, it's about money as well, right? And IO-centric optimization it's the best thing there, because if you focus on reduction of IO, I don't remember is it about writes or reads? I remember something different was there. This detail I already forgot. But either writes or reads, if you have them a lot, you need to pay for IO at Aurora. So you definitely want to reduce and keep have your buffer pool. You want your buffer pool to have better efficiency ratio in terms of hits versus reads, and just you can check your queries and optimize them and so on. And if, for example, indeed, if your index added more, for example, it broke all your hot updates, so hot updates ratio became 0. This is what happened with me a couple of times. In this case, you will start paying more. So you optimize one query, but not only you degraded, you have worse performance for other queries, but you're also paying more. It's not good. So my advice is know your workload, learn it from pgStar statements, for example, right?
Yeah.
Focus on buffers, not timing when optimizing. Timing is our final goal for optimization, but it should not be used during the process of optimization. It should be only like checked in the beginning and the end. But inside of the process of optimization, we should be focused on buffers. And finally, experiment a lot. And to experiment a lot, you should just be ready to clone and reset a lot and so on. That's why thin cloning is good. And as I've said, Aurora has thin cloning, so you can run additional node and test it there and stop it. I guess they have also like per minute or even per second billing as AWS in general has. EC2 nodes, they are per second, so it can be very efficient. You will need to wait some time, like minutes, to provision a node, but then at least you can quickly stop it, right? But pure thin clones, which are, I name them local thin clones. So we have one VM and many clones inside it. So we pay only for one VM. It's the best for experimenting. So having such platform for experimenting is a good thing. Anyway, general advice is experiment a lot.
Yeah. Sounds great. Anything else you wanted to add?
No, as usual, subscribe, like, share, provide feedback. Feedback is very important. Share is also very important in your social networks, working groups, Slack, Discord, Telegram, what you use. Please share and bring us more ideas. Actually, we have a queue of ideas anyway, but we want more.
Yeah, exactly. It's not just always request comes in and we do the exact topic. Sometimes it gives us an idea for a slightly different one, or we put two together and that makes a good episode, that kind of thing. So we'll see.
Exactly.
Thank you so much, everybody. Take care.
Bye.
Cheers, Nikolai.